Okay, let's give you guys some more practice. So in November 1959 in Hawaii, there was a volcano eruption. It shot the lava from a vent that was located at the bottom of the crater. Well, anyway, it shot the lava up to a height of 579 meters. Okay, so find the velocity at which it left the vent, which happened to be at the bottom of the crater. Okay, so all that you know is that Hawaii is on planet Earth, so gravity equals 10 meters per second squared. Okay, and it's shot up to a maximum height of this. Find the velocity at which it left the vent. Whenever you're doing projectile problems, try to visualize the three graphs. Your acceleration time graph, your velocity time graph, and your displacement time graph. The velocity is blah blah blah. Sorry, the acceleration is negative 10. Remember, because gravity is 10 meters per second squared, and so on. Try to visualize these three graphs, and then try and identify where this number fits in, and then try to identify what you're trying to find out. Here, in which case, here you're trying to find out the initial velocity at which the lava is being shot up vertically. Okay. Well, anyway, gravity is g equals well, I'm just going to say 10 meters per second squared here, but you got to take later you got to take negative into account because you got to take direction into account. Well, anyway, find out the velocity at which the lava was initially shot up at. Okay, find the velocity. So press pause and have a go. Okay, so to do this here, try and draw your three graphs here. So acceleration on Earth, we're going to say negative 10. So your acceleration time graph, your acceleration time graph will look like this, negative 10 here, and your velocity time graph, well, it's being shot initially at whatever, but your velocity time graph will look like this. Okay, and the equation for this line is well, I'm just going to call this x. That the initial velocity is what we're trying to find out. The equation for this diagonal line here is given by v equals x minus minus 10 10t. Okay, so when you have an acceleration of minus 10, it it will give you a gradient of minus 10, and your displacement time graph will look something like this. Okay, and the maximum height here will line up with this, with the velocity being 0. So at maximum height, the velocity here is 0. Okay, well try and visualize these three graphs. So the most useful graph is this one here, the velocity time graph. You're trying to find out the initial velocity, which is this x here. So once you've got your velocity time graph, you see it's the area underneath here that represents the maximum height. The maximum height happens to be this. So try and work out the area of this triangle here. Once you've got the area, then it will lead you, well, first work out the area of this here. So the area would be, hang on, the area would be, well, to work out the area of this, hang on, your velocity time graph will look like this: x, and then v equals x minus x minus 10t. Okay, minus 10t. Now you need to know this point here, the time at which it reaches the maximum height. Well, when it reaches the maximum height, the velocity will be 0. So you've got to put 0 into the v and try to solve this here. You're trying to find out the time at which the velocity will be 0. So so now add 10 to both sides. That will give you 10t equals x, and then t equals x over 10. So you see this, the time at which the velocity will be 0, or the time at which the lava will reach its maximum height is x over 10. It's this time here. Okay, so you know that this is x. You know that this is x over 10. So the area of the triangle will be the height, which is x, times the base here, which is x over 10, and then you've got to divide it by 2 because it's a triangle. Okay, so the area of this triangle here is given by this. Okay, and remember the area of the triangle represents the maximum height. So you can say the maximum height. You can say, hang on, you can say the maximum height equals this here. So this x here is the height of this triangle here. Okay, is the height of this triangle here, and this here is the length of the base here, which is the time it takes to get to the maximum height. This is the time at which it takes to get to the maximum height, and then you've got to divide it by 2 because it's a triangle. Okay, yeah, if you get the height times the base, it will give you a rectangle. If you want a triangle, then cut it in half. Okay, so the maximum height is given by this here. Now x gets multiplied to the top, giving you x squared over 10, and then when you divide by 2, it gets multiplied to the bottom. So it will give you this. So this here is our maximum height, but we know the maximum height is 579 meters. So put that into the maximum height, and then it's us working out x. Remember, x represents the initial velocity. So blah 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 times both sides by 20. So that will give you this here, and then square root both sides. So that will give you x being this. So this was the initial velocity at which the lava was shot out. Okay.